first question was asking, what is the probability that the student is wearing sneakers? And we're given information that 10 of the boys are wearing sneakers and 2 of them are not wearing sneakers. And we're also given the information that 4 girls are wearing sneakers and 12 of them are not wearing sneakers. So then we totaled that up. So for the boys it would be 12, the girls it would be 16, and the total of them altogether would be 28. So for the first question, to find the probability of the amount of students wearing sneakers, that would be 14 out of the total of 28, which would be reduced to 1/2, which is 0.5. And then the second question asks, what is the probability that the student is a girl? So this probability the student is a girl would be 16 out of the 28 total, which would be 0.57. And then the third question asks, does the probability of the student wearing sneakers and the probability of being a girl equal the probability of wearing sneakers and being a girl? So you would multiply the probability of the sneakers, which would be 0.5, by the probability of being a girl, which would be 0.57, which would get you 0.285, and then you would calculate the probability of wearing sneakers and being a girl, which would be 4 divided by 28, which would be 0.142, which is not equal to the 2 added together, which was 2.285, so they are not independent.
Okay, so for the textbook problem, Mr. Rexinger is playing a game with his students. He has to, one of the students has to guess the probability of someone having long hair in the class, and the person who wins gets a lunch pass. And so, wait. So it's asking who has the greatest chance of winning a lunch pass if they guess the student has long hair. And so you would want to guess for short hair, because that is the greater probability of that happening instead of long hair. And then for B, it is asking, Mr. Rexinger tells the person that the mystery student is wearing jeans, and should the person change their guess? And the answer to that is no. There's still a greater probability of picking someone who is wearing jeans. And then for C, are the events not having long hair and wearing jeans associated for the students? And it is yes, they are associated. And then for D, are the events not having long hair and wearing jeans mutually exclusive? No, wearing jeans plus having long hair can occur at the same time.
Okay, so for the problem that we made up, we are talking about Professor Snape's potion glass at Hogwarts, and the probability of like houses and whether they're a boy or a girl. So the first part of the question asks, what's the probability of being a boy and a Slytherin? So we would look at our table, and we would look at there's the boy and Slytherin. So that's 4 out of 10 students. And then the probability of being Hufflepuff and a girl, which would be 2 out of 10. And then the third part of the problem will be, are the events of being a Hufflepuff and being a boy independent? And we would set it up so the probability of being a Hufflepuff, given the probability of being a boy, should equal the probability of being a Hufflepuff. So the probability of being a Hufflepuff is 5 out of 10, and the probability of being a boy is 7 out of 10, and those two are not equal. So the events of being a Hufflepuff and being a boy are dependent.